So welcome to our second video in this series on polynomials, and in this one we'll be looking at how we divide polynomials. So we're going to be dividing polynomials by linear factors, and then we're going to look at how we can use that to help factorise cubic or quartic expressions. Now previously in the course we've had a go at kind of adding, subtracting and multiplying with polynomials, so we've just got division to finish off with. And we saw in the previous video how we can use factorising as a way of dividing and simplifying fractions. In this video what we're going to be doing is actually looking at how we can use more formal methods of long division to help us divide polynomials and finally factorise them. In order to do that, we need to go back and remind ourselves how to do long division. Long division is a bizarre old thing whereby it might be you got taught it at primary school and then it's not really regarded as a particularly important skill at GCSE, so you probably haven't seen it for a while, so we've just got to go back and just remind yourself how to do a long division. So let's get that bit done first. So two for us to have a go at. First one, A, we've got 1092 divided by 42, so we're going to set it out as for short division as a good old bus stop, and proceed the same as before, so 42 into 1 clearly doesn't go, 42 into 10 doesn't go, so we're going to do 42 into 109. That goes twice. At this point we'd be thinking, okay, what's our remainder? And then we'd be putting the remainder up in the air up here before moving on to the next part of division. All that long division does is just gives you a bit of a different structure for working out what that remainder is. So we know two 42s went in, that's 84. So the remainder we've got is going to be done just by doing a subtraction here. So we're going to do this subtraction underneath here. There we go, and we've got a remainder 25, and it's the 25 that normally in short division you'd be putting up here, but instead of putting the 25 up here, what we're going to do is bring the 2 down. And so now we're doing 42 into 252, and as clearly we all know our 42 times table off by heart, we know that goes in 6 times, and it goes in exactly what remainder have we got. Well, we know we've got remainder 0. It seems a bit daft putting that in, this 0 here, but you'll see the importance of that a little bit later on. So there we go. So answer to our sum, 1092 divided by 42 is 26. Job done. On to part B. Slightly more difficult because the numbers are a bit bigger, but the technique is going to be exactly the same. So here we go again. So we've got 76 into 1, 76 into 17 doesn't go, 76 into 173, clearly that goes twice. 2 76s, 152, and so we've got a remainder of 21. And again, that 21 in short division would just be put there. All we're doing is just creating a structure down here to do it. So let's bring down the 9 now. There it goes. 76s into 219. That's going to be 2 of those again. 152, same as before. What remainder have we got? We've got remainder 67. And then finally, all we've got to do is just bring down that final 6. There we go. 76s into 676. A bit of working out tells us that 876 is 608. So what have we got as a remainder? Do the subtraction. We've got 68. You'll notice here we've got a remainder of 68, whereas previously we had a remainder of 0. So that one went in exactly. Here we've got a remainder. So that's how you describe that, and there we go, there's our answer. So now all we're going to do now is just take exactly the same technique and apply that to polynomial or algebraic expressions. So here we go, we've got a question. It says we've got to divide a cubic, 3x cubed minus 8x squared plus 9x minus 10. I'm going to divide that by a linear factor, which is x minus 2. So here we go, there's the bus stop again. So now we've got to think about, well, how many lots of x minus 2 will fit into 3x cubed? And all we're going to do is say, well, x times what gives us 3x cubed? That's going to be 3x squared. So if I work out kind of 3x squared lots of x minus 2, there we go. This thing here is 3x squared lots of x minus 2, so that's 3x cubed minus 6x. The next step in our process was to work out what the remainder we have. So let's do the subtraction and see what's going to happen. Now clearly we've got to be really, really careful with signs here because we're subtracting this, so we're going to be subtracting the minus 6x squared. So we've got 3x cubed minus 3x cubed is 0, 8x squared minus 6x squared minus 2x squared. So that's how you've got to be really careful with these signs. So that's our remainder. So what we're going to do now, the next part of it was to bring down the next bit. In this case, we're going to bring down this 9x. And off we go again. How many lots of x minus 2 fit into minus 2x squared plus 9x? And if we multiply by minus 2x, that's what's going to create the minus 2x squared bit here. I've got to be honest, I don't really care what it does to this bit. I just want to make sure that this turns out to be the same when we do the subtraction. So minus 2x lots of it creates that expression, minus 2x squared plus 4x. And again, careful with the signs with times by minus 2, so we can just have a little look and make sure you're happy as to why that sign there has become a plus. And once you're happy with that, let's do the subtraction. So again, we're saying minus 2x. So if you have a look at this column here, those things are going to disappear. 9x minus 4x is 5x. Last job, bring down the minus 10. And off we go again in our final step. How many lots of x minus 2 are going to fit into 5x minus 10? Well, the answer to that is 5 of those. And here you'll notice we've got two expressions the same, so when we do the subtraction, we end up with 0. And that's why that 0 is important there, so you can see kind of we've ended up with 0, which means x minus 2 goes into this cubic exactly. As it turns out, it means that x minus 2 is a factor of 3x squared minus x squared plus 9x minus 10. But there we go. When we do that division, there is our answer. So 3x cubed minus 8x squared plus 9x minus 10, divide all that by x minus 2, you end up with 3x squared minus 2x plus 5. Okay, so hopefully you can recognize that the principles that we've used are identical to what we saw on the previous slide. Okay, on we go to part B, and it says we're going to take our cubic and write it as a product of a linear and a quadratic factor. Our linear factor is going to be that one there. Let's just see what's going to happen and where this quadratic is going to come from. I'm fairly sure you can guess it's going to be related to this one down here. So we know that we can write division essentially as a fraction. So that's the sum we just did. We said, okay, let's take this cubic divided by x minus 2. All we're going to do now is simply just rearrange that, move the x minus 2 over to the other side, becomes a multiply, and so now there we go, we've got our cubic written as a product of a quadratic and a linear factor. Okay, on we go. Another question we're going to have a look at, we've got again a cubic function. We're going to divide it by a linear factor. Now this one has got a slight issue, and the issue is there. You'll notice we've got 2x cubed, 7x squared. The x coefficient, or the x term, is actually missing. Now, what that does, that creates a real problem when it comes to doing our division and making sure that the columns line up. So we've got to kind of find a way around that, and the easiest way to do that is just to say, well, okay, let's include that x term, but give it a coefficient of 0. So what I mean is, let's just write it like that. Hopefully you're happy that what I've got down here now is exactly the same as what I've got written up here. Okay, so now I've got cubes, squares, the x terms, and the numbers, and now everything's going to work out quite nicely. So here we go, off we go with our division. How many times does x plus 3 fit into 2x cubed? Well, that's going to be 2x squared. 2x squared, lots of this thing here, is 2x cubed plus 6x squared. Do the subtraction, work out what our remainder is. Those are going to disappear. Do the subtraction here. I've got 1x squared. This is where it's important we had this, because we've got to bring down the x term. So we've got that. And now we're saying, okay, well, how many lots of x plus 3 fit into this? Well, that's going to be x lots of it. And you can see the importance of having this 0 here, because now we've lined up with our columns with our 3x and our 0x there. Again, do the subtraction. We've got 0x minus 3x. That gives us minus 3x. And then finally, bring down the minus 9. And say, well, how many lots of this fit into here? Well, hopefully you can see that's going to be minus 3 lots of it. There we go. Do the subtraction. It all cancels out. So we've done our division, and there's our answer, 2x squared plus x minus 3. So we know that our cubic here can be written as a product of our linear factor and our quadratic factor. So we're going to use that to factorise fully. So there's our function. It's factorised because we've taken out a linear factor, but it's not factorised fully. What we've got to do is factorise our quadratic factor there. So let's have a go at doing that, and that factorises quite nicely. So there we go. Now that's factorised fully, and there's our complete factorisation. We've taken our cubic and written it as 3 linear factors. Okay, it says hence sketch the curve y equals f of x. So let's have a think about what that's going to look like. Well, y equals f of x. fx is a positive cubic, so that tells us about the shape of the curve. The y-intercept, when x is 0, we're just left with a -9. So we've got a y-intercept there. And where is it going to go through the x-axis? Well, the x-intercepts would be if y is 0, if we had a 0 equal to all of this, what would our values be coming out from here? Well, solving that, hopefully you're happy that that would be -3 coming from that first factor, -3/2 coming from the next one, and 1 coming from the last one. So we know the shape of the curve, we know where it's going to go through the axes, so now we've got enough to be able to sketch our curve. Here we go. There's a set of axes. First we're going to do is put on those important values on the x and the y axes, and now we've got to get our cubic curve to go through all of those points, and the only way we can do that is if we have the shape of the curve like that. And there it is. There's our sketched curve. Job's a good one.